This video will discuss section 12.3, which is graphing other trig functions. This section is going to be broken down into two videos. The first video will discuss tangent and cotangent. The second video will discuss secant and cosecant. So to start off, let's discuss tangent and cotangent. These are probably the most different as far as the graphs go. Again, if you recall, tangent of theta is equal to sine of theta divided by cosine of theta, or y divided by x. So when you're looking at your unit circle, for the first quadrant here, we list some of the tangent values again, remembering that tangent is y over x. We're taking our y value, the 1/2, divided by the root 3 over 2, and in this case, rationalizing the denominator to get root 3 over 3. This one's a little bit easier to see since at 45 degrees, or pi over 4, since they are the same number. You divide by itself, you get 1, and so forth and so on. But you can also see here at the axes, you have your y value being 0. So you would end up with 0 divided by 1, which is 0. Similarly, at pi over 2, you've got a y value of 1, but an x value of 0. So in these cases, you've got 1 divided by 0, which is undefined. And so in that case, that creates this asymptote that we have here at pi over 2. Similarly, you see how this is repetitive. These are still cyclic functions. It's going to have an asymptote at negative pi over 2. So that's down here at negative pi over 2 or 3 pi over 2 as well. We've got, again, that x value being 0. So that's going to create this cyclic pattern with these asymptotes. We start off with very small ratios, very large negative ratios, and then we increase until we get to the 0, like we said, at the x-axis on the unit circle, so 0 divided by 1, and then we continue up until we get very large ratios again, because we are dividing by 0 then at pi over 2. Similarly for cotangent, if you recall, cotangent of theta is cosine over sine, and so that would be x over y. So we're going to have the opposite instead. At our 0 degrees or 0 radians, our x value is 1, our y value is 0, so we're dividing by 0 here at 0 and at pi. So that's where we get our asymptotes for our cotangent function. Again, these are just taking those ratios of either y to x or x to y. And it just follows this kind of S-shaped curve, if you will, and that's what the cotangent and tangent functions look like. If you increase the amplitude, as we have seen before, it will stretch things out. This will get a lot steeper if you have an amplitude that is greater than 1, and it'll get a little bit more level here if you have an amplitude that is between 0 and 1. Negative, of course, will flip it over. It'll give you a mirror image, and the period shift would be the same as it was when we were talking about sine and cosine. So we're going to come back and talk about the graphs for cosecant and secant here in the next video. Let's again remember the definition for an asymptote. Definition for an asymptote is a line or curve that approaches a given curve arbitrarily closely. So again, we had those asymptotes. We talked about those. Those are going to show up in all of the tangent, cotangent, secant, and cosecant functions are all going to have asymptotes. Period for tangent, as you can tell, this is going to be a little bit different. If you look at the unit circle, you notice that it only goes over here to pi, and that's where you have that asymptote, and then it starts again. So we've only got half the period that we did before. So the period for tangent and cotangent is actually just pi. Or if we have an adjustment, we end up with pi over b again. Again, we'll come back and talk about secant and cosecant in the next video.